Welcome to Mr. Academia YouTube channel. We thank you for viewing all our lessons. We request you to press that subscription button to enjoy more of our lessons. Share our lessons with your friends, like and also comment on our lessons such that we can have the best out of our lessons. Today we are going to look at simultaneous equations and how we solve simultaneous equations. So basically, if you look at an equation which is like this, or an equation which is in this format here that we are looking at, so such type of equation is what we call a simultaneous equation. So you can see we have two unknowns. The first one is x and the second one is y. And we have two equations where we have to look for two unknowns. So this equation is what we call a simultaneous equation. So these two are called simultaneous equations. So in this lesson, we shall be able to understand what simultaneous equations are. Then we shall also solve simultaneous equations graphically, and we shall also solve them by elimination method and also by the substitution method. So meaning that we shall apply all these three in solving simultaneous equations. If we look at the meaning of a simultaneous equation, if we have any equation with just one letter representing an unknown, like this equation here, we only have x, which is not known in this equation, but 2 is a known number and 8 is a known number. So meaning that in this equation, we can easily get what x stands for by just taking this to this side, and we get x as being equivalent to 6. So this equation here can easily be solved because we have only one unknown. But now, if we look at two equations which are like this, we have two equations with two unknowns. So these two equations are what we call simultaneous equations. So simultaneous equations are two equations with two unknowns. So when solving the two, we just find the common solution to the two equations. And when we get the two common solutions to the two equations, we say that we have solved the simultaneous equation. So basically, if they ask you to solve simultaneous equations, they are asking you to find the value of x and y that fit both equations, or the values that satisfy all the two equations, which we call simultaneous equations. So let us look at the first method of solving simultaneous equations, and we are going to look at the graphical method, and these are the steps which are involved in using the graphical method. So the first step is that we shall draw a table of graphs for the two equations, and then after drawing the table of graphs, we shall extract a set of coordinates for the two equations, which we plot on the same graph paper. We extract the set of coordinates and then we plot those coordinates for the two lines on the same graph paper. So the graphs which we draw, we draw the graphs or lines for those two equations, and then we label them. And then the points where the two graphs meet, or the points where the two lines meet or they cross each other, those points, they give the answers, or that point gives the answers for the two unknowns, or what we call the value of x and the value of y, if we are dealing with x and y. If we look at if we look at our next slide, we have an example here where we are supposed to solve these two equations, y equals 3 minus x and x plus 2y equals 4. So in solving this, we are going to use the graphical method basically. So we first draw tables for the values. For example, we select a range of values for x ranging from -3 to +3. So meaning that we shall have -3, -2, -1, 0, 1, 2. So we just substitute values of x in this equation here, and we find the corresponding values of y. For example, when x is -3, y will be equivalent to -3 minus 3, and this will equal to -6. So that's why we have the value of y here as -6. So we do the same for x equals this, we get this, so we get this. So finally we shall have a set of coordinates which can be extracted, like -36, -25, -1403, 12, 21, and 30. So we do the same for the second equation, also using the range of values of x from -3 to 3. We do the same and we find also the set of coordinates for those values. So the next step, we are now going to plot the set of coordinates. So you can see here that we have plotted two lines. The first line is here, and this line here, you can either name it from the graph, but in this case, they've named it from here. So if you want, you can also name it from here as y equals 3 minus x. And then this other pink line here is the line x plus 2y, x plus 2y equals 4. So when the two lines are drawn, the values of x and y that solve the two simultaneous equations are the values of the coordinates where the two lines meet. So you can see the lines meet at this point. So meaning if you are supposed to read the coordinates of that point, and the coordinate is 2, 1. So this means that the value of x will be equivalent to 2, and the value of y will be equivalent to 1. So these two values are the ones that satisfy the two equations, and then we say we have solved the two equations simultaneously using graphical method. So you can see the lines cross at x equals 2 and y equals 1, and therefore we say we have solved the two equations when we get that as our answer. So that is the graphical method of solving simultaneous equations. So now let's look at another method of solving simultaneous equations. And this time we shall look at the substitution method. So in the substitution method for solving simultaneous equations, we shall start by looking at an example where we have x plus y equals 5 and y equals 3 plus x. So the first step that we always do is that we solve one of the equations. We solve one of the equations for one variable, and then we substitute what we've got in from one equation to another equation for the variable which we've got, and then we go ahead and solve the equation. So like for example, the second equation is y equals 3 plus x, so meaning that we shall not, but the first, maybe if I'm to name them, this is equation 1 and this is 2. So the second equation is already in terms of y, so meaning that y is expressed in terms of x. So we shall now use the value of y in equation 2 and substitute it in equation 1. So that's why here at this step here, where there is y, we shall substitute 3 plus x. So the equation becomes x plus 3 plus x equals 5. So we go ahead and we solve for x. So if you go ahead and solve for x, we get x as being equivalent to 1. So we have already got the value of x. So after getting the value of x, now the next step is that we go back and now we substitute in the value of x that we've got into one of those two equations, and we find the value of y. So you can either use the first equation or you can use the second equation to get the value of y, provided you found x. So in this case, I used the first one and I got y as being equivalent to 4. So if you want, you can also go ahead and check your two answers to see if they are correct, and you realize that the answers are correct answers since they satisfy the two equations. Maybe for another example, using substitution, it is also here. So this is the other example which uses substitution. You can see how they are substituting here. They first expressed x in terms of y, and then after they substituted for x into this equation here, and then they went ahead to solve and get x and y, and this is what they get finally as the value of x and the value of y. Yeah, so basically that is it, and that is how the two equations are solved. So let us now look at the third method, which is the elimination method. There are several methods, and now if we look at the elimination method, it is one of the other methods of solving simultaneous equations. So it involves the following steps. First of all, we organize the equations. We make sure that the coefficients are equal. We eliminate a letter, and then we solve the equation, and then we substitute. And then if you want, you can also check your answer to see if the answer is correct. Maybe we can look at an example. For example, look at this one here. We have two equations, 2a equals 16 minus 5b and a plus b equals 5. So we first arrange them to make sure that the value of a, the value of b are all in similar positions. So that's why the equations are rearranged like this. And then we have a occupying the same position, b the same position, and the other whole numbers or whole values are also occupying the same position. So after doing that, we now go ahead and move on to the next step of solving the simultaneous equations. So the next step, when using the elimination method, we make sure that the coefficients are equal. So to make coefficients equal, we need one. For example, if you want to eliminate a, you make sure that the coefficients of a are equal. If this one has 2a, we also make sure that the second equation also has a coefficient of a, which is 2a. So to do that, since we want to eliminate a, we shall multiply the whole equation with 2, such that this equation here will end up becoming 2a plus 2b equals to 10. So every number in that equation is multiplied by 2. So finally, we realize that now the coefficients of a are equal as seen in these two equations down here. So the next step after this one, as we can see, is now we get rid of a. So you perform an operation that eliminates a. So depending on what the signs of a are, so in this case, 2a here is positive in the first equation, and 2a is also positive in the second equation. That means that the only way of eliminating a is by subtracting the two equations. So if we subtract 2a minus 2a, this gives 0. 5b minus 2b, that gives 3b. 16 minus 10 gives 6. So meaning that we shall now be remaining with solving 3b. 3b is equivalent to 6, where you can go ahead and divide by 3 both sides, and then you get the value of b as b being equivalent to 6 divided by 3, which is 2. So that is how we now get the value of b. As you can see here, this is the easiest part, where you just divide by 3 and get b as 2. So after getting b as 2, now you substitute the value of b in any of the two equations that we had, equation 1 or 2, to get the value of a. So if we substitute in the second equation, we get the value of a as 3, which you can go ahead and test with any of the two equations, or you can test with all the two equations to see if your answer satisfies all the two equations. So basically, that is how we do solve simultaneous equations using the 3 methods of solving simultaneous equations. So remember to subscribe to our channel to enjoy all our lessons, like our lessons, share and comment to enjoy full package out of our lessons. Thank you.